This final chapter, Chapter 6, contains 8 quiz questions to test your understanding of the materials in this module. Question 1. Which of these is most likely to be the price of a 10-year zero-coupon bond if you know the yield curve is completely flat and that a 5-year zero-coupon bond from the same issuer is trading at 80? The 4 possible answers appear now. Solution to question 1. We know that the price of the 10-year zero must satisfy the equation appearing here, since the price is simply the face value discounted at 1 plus y to the power 10 for 10 years. By the same token, the 5-year zero must satisfy the equation here, P5 equals 100 discounted at 1 plus y to the power 5, but we are also told the 5-year zero is worth $80. From this, it automatically follows that 1 plus y to the power 5, simply inverting the above equation, is 1.25. Going back to the price of the 10-year zero shown above, we know that 100 over 1 plus y to the power 10 is nothing more than 100 over 1 plus y to the power 5 divided again by 1 plus y to the power 5, which is therefore equal to 80 divided by 1.25 and is equal therefore to 64. So the correct answer is D as in David. Question 2. You bought a 20-year bond with a coupon of 6% and a face value of 100. What is the maximum price the bond could possibly reach under any interest rate scenario where interest rates cannot be negative? Here are the 4 possible answers. Solution to question 2. From the fundamental pricing equation for a bond, we know that price equals the discounted PV of all the future cash flows, as shown here. If we now set y equal to 0, all the denominators become 1 and disappear, and therefore we get price equals coupon times frequency times number of periods plus 100. In this case, this comes to 6 times 1 times 20 plus 100, which is 220. So the correct answer is D, as in David. Question 3. A bond with a 10-year maturity and a 5% coupon paid annually is trading at 95. Which of these is most likely to be the bond's current yield and its yield to maturity in that order? Here are the 4 possible answers. Solution to question 3. We reproduce here the table which ranks the yield measures based on the trading price of the bond. Since the bond is trading at 95, we are in the bottom row of this table, so the yield to maturity is greater than the current yield, which is greater than the coupon, and therefore the correct answer is A, as in apple. Question 4. A bond trading at 80% of par has a 30-year maturity and a modified duration of 20. If interest rates rise by 15 basis points, the price of the bond will do which of the following 4 possible things? Solution to question 4. We know that for small yield changes, our previous linear approximation formula says the percentage price change equals minus the modified duration times the change in yield. So in our particular instance, the percentage price change equals 20 times the 15 basis point yield movement equals 3%. Since our bond is trading at 80 and rates have risen, its price will therefore fall by 3% of 80, which is to say 2.4% of its par value, ignoring, of course, convexity. So the correct answer is A, as in apple. Question 5. Suppose interest rates in the previous example move down by 100 basis points instead. The bond's value would do which of the following 4 things? Solution to question 5. This time, since rates have moved by a more substantial amount, we will need to take account of convexity in addition to modified duration. The basic equation involving modified duration gives us a percentage price gain, since rates have fallen this time, approximately equal to 20%. The effect of convexity, as always, is to make gains a little larger than suggested by the linear approximation. Thus, the gain will be slightly greater than 20% of the bond's current price, and therefore the correct answer is C, as in Charles. Question 6. A U.S. corporate bond trading at 80 pays an annual coupon. Its Macaulay duration is 11 and its convexity is 100. Estimate its price if interest rates first rise from 10% to 11% and second drop from 10% to 9%. You should be able to do this question without using a calculator. Here are the 4 possible answers. Solution to question 6. We reproduce here the equation for deriving modified duration from regular duration, and also the equation for estimating percentage price changes given modified duration and convexity, and of course a change in yield. From the first equation, it follows that the modified duration of this bond is exactly 10, as you can see here in the bottom row of the slide. In turn, this allows us to calculate a percentage change in price when interest rates have risen by 1%, equal to this quantity here, which simplifies to a loss of 9.5%, while the percentage change in price when rates have dropped by 1% equals this quantity here, which simplifies to a gain of 10.5%. Therefore, the correct answer is D, as in David. Question 7. Which of the following is true of a bond's duration measures? Here are the 4 alternative statements to choose from. Solution to question 7. A bond's duration and modified duration increase as we lengthen maturity. The easy way to remember this is to think of a bond's duration as the average time it takes to receive the present value of the cash flows under the bond. A bond's duration increases as we lower the coupon. The easy way to remember this is to recall that a zero coupon bond has a duration equal to its maturity. Therefore, the correct answer is B as in boy. Question 8. I wish to own a bond with high convexity to benefit from anticipated interest rate volatility. To maximize convexity, I should purchase which of the following 4 alternative investments? Solution to question 8. Convexity's reactions to coupons and yields run exactly parallel to those of duration and modified duration. In the case of duration, we saw in the previous question that it increases the lower the coupon, and therefore to maximize convexity, I should buy a low coupon bond instead of one with a high coupon. We explained also in the previous question that in low yield environments, a bond's price sensitivity would intuitively be higher than in high yield environments. So to maximize convexity, I should seek markets with low yields. Therefore, the correct answer is D as in David. This now completes the quiz and the entire module.